In this video, I'm going to demonstrate how to use SPSS to carry out a split half interrater reliability assessment. And in this study here, we have 8 research participants that were evaluated on a categorical scale on 10 questions, or what we just generally refer to as 10 items. And the scale was identical for each of the questions, and the scale ranged from a low value of possibly 1 to the highest possible score of 7 on this particular scale. And so to carry out the split half reliability assessment, I'm going to analyze, I'm going to go to scale and reliability analysis. And the first step I'm going to do here is I'm just going to pull all of the items over to the items box on the right hand side. So I'm going to click the first one, then I'm going to hold the shift key down on the keyboard to highlight all of the particular items I want to pull over, and I'm just going to move them over to the items box. Under statistics, I'm going to click scale. And there are a number of other options, but I'm going to ignore those here in this video, and I'm just going to use scale, and I'm going to continue. And under the model, I'm going to select split half. And now I'm ready to conduct my analysis. And so what we see here in our output, we have a summary of the cases that were processed. So we have a total sample size of 8. None of the data were missing, so all were included in the analysis. Now, when we use this approach, what SPSS will generate is Cronbach's coefficient alpha, but notice here we have 2 different coefficients, and the Cronbach alpha, it was carried out in 2 parts. The first collection of data, and under the superscript A, that refers to items 1 through 5, and the interrater agreement was 0.813. For the latter 5 questions, items 6 through 10, the interrater agreement was 0.738, and note that it was 5 and 5. Now, the Spearman-Brown coefficient is the split half coefficient that makes an adjustment for the fact that all 10 items were simultaneously considered. Note that Cronbach's coefficient alpha does not make that adjustment. So the split half or Spearman-Brown correction has an interrater agreement that's considerably higher at 0.92. And notice that we have 2 items or 2 options here, equal length and unequal length. These coefficients are the same, and the equal length is a calculation when the number of items are even, and the unequal length occurs when the number of items are odd. But in this case, since the numbers were even, both will come out to be the same. Thing. Now I'm going to rerun this analysis slightly different. So I'm going to go back to Analyze. I'm going to go to Scale, Reliability Analysis. Now I'm going to take these items and I'm going to pull them back over to the left-hand side. And now I'm going to enter the items into the box in a different order. So I'm going to enter all the odd numbered items first. 3, 5, 7, and 9. And now I'm going to enter in all the even items. So numbers 2, 4, 6, 8, and 10. So I'm still on split half, so I'll go ahead and just hit OK. And what we see here, when we do this from the output window, that the first output is maintained, the first analysis, and then the second output is appended to the first analysis. So what we see here for the Cronbach coefficient alpha, once again we have 2 parts, each have a sample size of 5, so that it's split in half. But take a look at the correlations. The correlations are quite a bit different than what we had in the first analysis of 0.813 and 0.738 for the second half, and here we have 0.759 and 0.772. So the order in which we enter the items for the interrater reliability analysis does have an effect on the outcome, not just on the individual half of the data with the Cronbach's alpha, but the split half coefficient, which makes the correction, will also be slightly modified through the Spearman-Brown coefficient. So in our first analysis, when all the items were entered in numerical order, we have an agreement coefficient, a split half coefficient of 0.92, and notice that the split half coefficient is slightly changed, slightly elevated at 0.948. So it's really important from a research design perspective, for researchers to decide which items are of greater importance, and which ones are important will dictate how these are entered into SPSS in order to carry out this analysis. So this ends our video on using SPSS to carry out split half correlation analysis.